National Technical Systems, NTS, which is about to become Element. And we're here at a Boston EMC chapter conference. And there's a bit of a trade show here. Let me kind of show what's going on down here. There it is. And we're going to look at this demo here. And Jason Smith is going to tell us about what we've got going here. We've got some equipment, we got some filters, we got a fan over there that's being used as a source of emissions, you might say, something that fails emissions. So, Jason, why don't you tell us what we've got going here?
Sure. Hello, I'm with Absolute EMC. So we represent and sell the product. This is an M-Scope from Emser. This unit is a unit for doing conducted emissions measurements. We have a built-in LISN, line impedance stabilization network.
Okay.
That the outputs of those LISNs feed into two independent receivers, and so those two receivers can measure both the line and the neutral simultaneously. Mm-hmm. And then in the setup here, we're going through a filter box to kind of demonstrate fixes of our EUT. So our equipment under test is a PC power supply that fails.
Okay.
And so we were able to show what's going on with our unit here. So for normal testing, we would set up our measurement to measure EMI. So we can do line to ground, quasi-peak. We can add another trace here. We can do line to ground average. And so we have two traces for line to ground for quasi-peak and average. And we have our limit lines here. And as we see, we were failing all of our limit lines. Mm-hmm. Now, normally if you would do that test at the test lab, you would need to fix your product. And one solution for fixing your product would be to put like a full filter and find a solution to fix your...
Okay, so here we've got some filters.
Yep.
That's these in here.
Yep.
These are filters.
Yep. So right now we're just bypassing it, so we're not going through any filters.
Okay.
So if we go through and go to the filter, the first one here, which is a full filter, it's got a common mode and differential mode choke. We turn that in, and now we pass.
Okay, so we're passing AC power through here out to the power supply.
Yes.
Okay.
Yeah. Without the filters, turned in, it just bypasses it. Right now, we turned in the first filter, which is a full filter. And then, so when we do that, our results now show our passing.
Okay, and you can see the, just for people who don't know, there's a line right here. That's the limit.
Yep.
And we can see we're below, all the emissions here are all below the limit.
Yep. So there's two lines. One the top one would be the quasi-peak limit line, and the bottom one is the average limit line.
See.
Yep.
Mm-hmm.
And so now we kind of solved our problem with that filter, but if we go take a step back and look at the the failure again, we can look at it in a different way with this unit. Since we have two receivers built in, we can change how we're looking at this. We can go to our modal measurements, and we can change to a quasi-peak and a common mode measurement and a differential mode measurement. So now we're looking at, we're seeing the common mode is actually failing, while differential mode is not failing. So really what we need to do is to solve the problem. We don't need a full filter. We just really need a common mode choke in that. And so and we go back to our filter box. Mm-hmm. The second filter is actually just a common mode choke. So if we switch to that.
So the idea is that the common mode choke is less expensive than the full filter.
Exactly.
Okay.
So your solution is a cost savings.
Okay.
Yep.
Okay. And what's this one here? Is that just a pass through of some kind?
So that the last one is just a differential mode capacitor.
Oh, okay.
Capacitor between the two lines.
Mm-hmm. Yep.
So now we look at our screen here with just a common mode choke. We pass again. And then I can switch into the last one, which would be just the differential mode capacitor, and we fail again.
I see.
Yeah.
Okay, very good.
Yeah.
Thank you.